Um, to find the volume of an object, basically we're going to use the formula big R. So R is going to be the outer radius from the rotation, outer radius, outer radius, and little r is going to be inner radius, and the formula is going to be V equals pi big R squared minus R squared, and dx or dy. And basically, that's basically it to volume. It's really not that difficult. There's disher and washer, but it's really just the same thing. It's just that in this method, I believe that this is going to be 0. Alright, so let's go through sample problems. And yeah, we should be good to go. So I'm just going to copy this over. Where is it? Alright. So if I'm rotating along the x-axis here, right? Okay, so basically I need to identify my big R. So from the x-axis. So when identifying your R, you're going to look from your axis of rotation, and you're going to go to see which one's the farther graph. From here, this is going to be f of x. That's big R, and this is going to be little r. Okay, and so the formula would be, so my axis is dx, right? So I'm cutting lines like this, right? Because my rotation is going to end up over here somehow, right? So it's going to be volumes equal to pi r squared minus, oh wait, pi f of x, because f of x is bigger, and g of x squared dx. And this is from like A to B. You know how to do bounds. Okay, and so let's see if I want to do volume. Just test volume. I'm an area. The area between this, let's call that A. The area is going to equal to, always going to equal to r minus little r dx or dy. So in this case, it's going to equal to A equals f of x minus g of x dx. And in the case of area, it's always going to be to the x or y axis, depending on which dx or dy you use. So if I use dx, my thing's always going to be to respect to the x-axis, r is going to be respect to the x-axis, and y is going to be respect to the y-axis, right? So let me review what f of x means, right? So if I have f of x, basically, let's say I have y equals 2x, or f of x equals 2x. Alright, so on a graph, this looks like this, a slope, right? So if I plug in 1, right, I'm going to get 2. If I plug in 2, I'm going to get 4. So what it means for f of x, right, is that f of x is going to be the distance from the x-axis, right? And f at 2 is going to be 4. So when I say an integral of f of x, right, I'm doing this section. So let's just visualize area, and let's just visualize area and then to volume. So this is little r, right? So I'm going to have the section of f of x equal, so I'm trying to find the black space. I'm trying to find this black space, right? So this is area. So this is going to be my f of x, and this is going to be my g of x, right? So I want this area in between, so I probably should draw it here, right? So I want this area in between, so it's going to be the difference between these, the red one minus the blue one. And so the red one is going to be f of x. Back down here, where's my pencil? Oh, f of x minus g of x. And that's going to equal the area. Now for volume, it's important that you know how to do this because I'm rotating this, right? So I'm going to take this volume, right, and I'm subtracted by this volume, the blue volume, and then what I'm gonna be left with is the this volume, right, around it. So yeah, that's that. So let's do the next problem. Next example. Alright. So here we have f of y. So this is a function. I didn't make this clear, but this is a function, and that's also a function. And let's say this is x equals -2, and I'm rotating around. So it's a function of y, right? So I'm rotating around this, right? So when I rotate, I'm going to end up with another curve somewhere on this end, right? So I'm going for dy. So let's first identify what we're using. So v equals pi integral something dy. Okay, so dy. So let's big R. So let's write out big R and little r. Big R, so if I look at g of y, right? G of y is going to give me this distance, right? It's to the y-axis. Okay, so that's why it's important that I showed you that f of x, right, is going to be distance from the x-axis. G of y is going to be distance from the y-axis. So I'm going to have g of y, but then I had to add this extra 2 distance, So this whole thing is going to be r. So it's going to be f of y plus 2. And then now let's look at this little other distance. So that's going to be 2 plus f of y. So f of y plus 2. And our formula, right, is going to be big R squared minus little r squared. So we're going to get v equals pi integral of minus. So completion's sake, I don't know, so it looks nice. We have g of y. Where's my marker? This is so hard. G of y plus 2 squared, and this one's gonna be g f of y plus 2, and that's supposed to be that. What did I do here? Plus 2. Alrighty. So that's pretty easy. Alright, so what about Washer's method? I guess we already talked about that, but I guess I can make it. So let's say I just have a graph of this, like such as this, and I just have f of x, and I want to find the volume rotated around this, right? So I want this, right? That's dx, right? That's big R, but where's little r? Little r, there is no little r. So because there's nothing like in between the graph and the line of axis, right? So there's no little r. So I just say little r is 0. R equals 0. Big R equals f of x. So my volume is going to be v equals pi integral f of x squared minus 0 squared, which is just 0 dx. And that's basically that. That's wash this method, and that's this method. Alright. And yeah, okay, so we're gonna do one more. We're gonna do two more. One more. Okay. Really test your knowledge. Okay. If your geometry skill is really good, you shouldn't have a problem with this one. So, like I said, our axis of rotation, right? It's going to be around x equals 4. And x equals 4, right? So it's around here. So my shape's going to be around here. So I'm going to do dx. Dx. So v equals pi integral something dx. Okay, so what's big R? So big R so I am asked to find the region enclosed by f of x and the x-axis. So I want this region. I just made that up, but let's say I want this region rotated around. Okay, so I gotta find big R. So, what's big R? Big R is gonna be from your line of rotation here all the way to the farthest point. There. So how do I represent that? Well, it's always going to be 4 constant, so this is a constant 4, right? Because I'm going to take the volume of this box, and I'm going to subtract this bit, this volume. So it's going to be 4. So big R equals 4. And hopefully you see the Y, right? And then here's the hard part. Little r is going to equal to this bit, right? So I said f of x is going to give you this bit, right? But then I need this bit right here. So it's going to be 4. Okay, so f of x is going to give me this blue part, right? So I need this teal part, this turquoise part. So it's going to be red minus the blue. This is like the pendulum problem where you have like, this is like the pendulum problem where you have this theta, right? This distance is going to be L1 minus cosine theta, right? You have to think about it conceptually. So this part is going to be the cosine theta part, and this is L. This whole length is L. So you just subtract the 2 to get this. Alright, so that was off topic. So I have this bit 4. I have this 4 bit. Okay, and then I have this curve. I have this curve f of x, right? And I'm going to find this teal part. And from here it should be obvious that this teal part is equal to 4 minus f of x. So 4 minus f of x. And then from here we just plug into our formula. So big R squared, 4 squared, minus little r squared, 4 minus f of x squared dx. And yeah, that is volume.